Alright. Here we are again. Back to another video. We're going to start some quick discrete math basics. Like, the very first things you're going to learn. Oh, plus a little bit of intermediate stuff. So it's going to be a little bit of a mix. This is just stuff that I learned over this past week. Alright? I'm going to review it with you guys. Alright, 1. Necessary versus sufficient conditions. A necessary condition is one that is needed, while a sufficient condition usually meets and exceeds the condition required. For example, we have a square, rectangle, and quadrilateral, which is a four-sided anything, 2D object. Now, to make a rectangle, a square is a sufficient condition because it is four-sided, which is quadrilateral, and it has two parallel sides and 90-degree angles, not to mention that. However, to be a rectangle, you have to be a quadrilateral, which is why it's necessary. So to be a rectangle, it's sufficient to be a square, but you have to be a quadrilateral. Yeah. All right. Let me just say that again. To be a rectangle, it is sufficient to be a square, but it is necessary to be a quadrilateral. Alright, inverse, converse, and contrapositive. Original statement is if P, then Q. The inverse is if not P, then not Q. The converse is if Q, then P. The contrapositive is if not Q, then not P. The contrapositive, remember, is the only statement that is logically identical and equivalent to the original statement. For example, if I am famous, then I am rich as well, which means if I am famous, that implies that I am rich. The inverse is, if I am not famous, then I am not rich, which is not true. If I am rich, then I am famous, that's also not true, because if I am not famous, you don't have to be famous to be rich. All those billionaires up there who aren't really famous, but they are rich. And if I am rich, I am famous. Well, that's also false, because just because you are rich doesn't mean you're famous. See there? Just because you are rich, then doesn't mean you're famous, which means it's false. It's not identical to the original statement. The contrapositive, however, which is if I am not rich, then I am not famous. That is the same thing as saying if I am famous, then I am rich, because it's just the reverse. If I am not rich, that guarantees that I am not famous. However, if I am famous, then I am guarantees that I'm rich. See? So the contrapositive is the only statement of the inverse and converse that is identical to the first original statement. Now, this doesn't mean that original statement could be true or false. That's a different story. But it just is identical. It's logically equivalent. Now, the Morgan's law is just not A or B equals not A and not B. Not A and B equals not A or not B. Parentheses are different. The example is, I don't want either red or green toys. Also means I don't want red toys and I don't want green toys. I don't like crackers and cakes. It is the same as I don't like crackers nor cakes. And here's the tautology contradiction. Tautology is a statement that is always true. A contradiction is a statement that is always false. Let me just add something to that there. This is what a tautology looks like. For example, you have this here. All trues here. This is all true. Basically, for example, I am either a human or not human. That guarantees to be true. Either direction. You want to manipulate that. Now, contradiction, an example would be, this statement is false. That's going to be false either way you think about it. So that's what I learned, alright? I guess I'll see you all in the next video. Goodbye.